So the driver gear is the input power gear. Okay. So power will be input into the gear, and then we have another gear. Okay. This gear over here is our driven. And I'll call it DN. Okay. And this is the output power gear. Or you can easily call it power output gear, input gear. Now, if the rotation is in a clockwise direction, right? We know that the other gear will rotate in the anti-clockwise direction. Agree? Right? This is straightforward. Okay. The problem is with the forces. Okay. The problem is with the forces, and we have to know why it is doing this way. Okay. So at this point, this is our point of contact. Okay, this is our point of contact. Why I'm doing this slowly? Because everything is easy, right? Power is equal to 2 pi nt over 60. Torque is equal to force times radius. Every year, since I'm teaching this course 5 years ago to now, every year, students have the wrong conception on where the applied force is. Let me elaborate, okay? Let me elaborate, okay? Or not, you don't understand my frustration. Okay? And I don't want it to be my frustration anymore because I really want you all to know, okay? Right. So this is our DR, our driver gear. The driver gear is rotating in a clockwise direction. So the force that is transmitting is in this direction. Right? It's pushing in that direction, so this is the applied force. Yeah. Now, if we look at the driven, okay, if we look at the driven, it's going in the opposite direction, anti-clockwise. Right? We know that over here, because I split the gear up, these are our point of contact. Question is, in the driven gear, in our DN. Okay, so this is our DN gear. What is the direction of the force? Going up or coming down? How many of you say it's coming down? I used to say, how many of you say it's going up? It's one or the other. Okay, why going? I can tell you why I look at this as coming down. I'm not saying that which is the right answer. Why is it coming down? Because it's following the rotation of the what? of the gear? Yes or no? Why is it going up? Newton's third law. Action equal to reaction, same in magnitude, different in what? Direction. The right answer that is the resistance force. You understand? Yes or no? It's like, Lucas, come here, demo. Come here. Lucas, for now, you are not a very good son. Okay? For now. Okay? Demo.
Yeah.
So, Lucas will face you. Sorry about the sun. Okay? I think we have to stand here so they can see our. Oh, I did not turn on the camera. Wait, let me turn on the camera. I do apologize. Okay, there's Lucas. Okay, Lucas is the good son. Okay? I know, not a very good son. Like my daughter, when I say no, she will say yes. And I'm the driver, right? And okay, I'm the driver. And I want Lucas to walk the same direction as me. Okay? But Lucas will always do the opposite. Lucas will not follow me. He will do it. So if we say the direction is going the same way, if I push Lucas, Lucas will go the same way, right? But that's not the fact, right? Lucas has resistance, right? Lucas don't want to go where the applied force. So Lucas have this resistance over here. So when I push you, you push back. So I want to go forward. There is a resistance. Can you see that? But I still insist that he has to rotate in the same direction I'm going. So he's applying the resistance force. So as the motor, right? If I have to drive him, he will definitely what? Resist. It's like friction. Friction always applied in the what? Opposite direction. Yes or no? Think of it as that concept. Thank you, Lucas. Okay? Think of it as that way. Okay? So I'm also confused. When I look at this, the confusion is this. We are dictated by the rotation. Because the rotation is torque is equal to force multiplied by radius. If the torque is going in that direction, the force has to what? Follow. Yes or no? That's where I get confused. I took a long while to get this right. Okay, but you guys are young. I want you to get this right now. Okay, so the applied force, okay, and the resistance force carried out by the driven gear is always what? Opposite direction. Yes. Yes. Yep. Okay, it will always oppose. Okay. Right. So once you get that right, okay, this is where it's difficult. Why this is important? If you get this wrong, all your moments will be what? Wrong. Okay? So your moments will all be out of whack. Okay? So now, things that I elaborate on, there are two things. Yes. Don't think about the initial gear first. Let's sort this out first. Initial gear, we will do it later. Okay? Let's grab this concept first. Two things to look at. Okay? Point of contact. Okay? The applied force and the resistance force. Okay? Two things to what? Take note. Okay, this is critical. Now, let's look into this problem first. Then we talk about the third gear. Okay, let's go. Okay, So now, come back to here. The first thing that we have to identify now, okay, I need another page. Okay. First thing to take note now is to determine the points of contact. So for this example, okay, the points of contact is here. Okay, there's one point of contact here, right? There's one point of contact over here, okay? And there's another point of contact over there. Those are our point of contact. The next thing that we do is we are going to sketch the rotation of the what? Of the shaft, okay? So we know that the motor, okay, if this is our X, our Y, and our Z, okay? So being from X, these are how the gears will rotate. Okay? So let's look at the gear. Okay, let's do it. The applied force is going down this way. Right? This is your applied force. Okay. Now, if we look at H, can you see which is the direction of the applied force? Right? The direction of the applied force is going this way. Okay. These are the direction of the applied force. Applied force. Okay. Right? It's in. So how do I know that? So if you look at the applied force relative to here, to this axis over here, right? It's in this direction, right? So if I draw the radius over here, right? That is your applied force. Okay. Now, look at the gears at H and G. Okay, look at the gears at H and G. Then the resistance force, right, will go in what direction? Will go in the opposite direction. So this is our resistance force. Okay. Now I have a question. The applied force at GC and HG align with the z-axis. The applied force CG and HG, yes, they are aligned but opposite in direction. Okay. Those are the what? Resistance force. Okay. So when you calculate the moment, when we calculate the moment, we are going to calculate based on the what? Resistance force. Okay, when determine the reactions at point A and B and bending moment. Okay. Use the resistance force. Once you get this right, okay, then we're okay. If we don't get this concept right, okay, that's where the problem will come. Okay, are we clear? Okay, so what I'll do is I'm going to stop here. Why isn't A and B resistance? A and B, at point A and B travel, it is where the ball bearings are housed. Okay, so bearings are so-called frictionless. Trevor asked why A and B, there are no forces, okay, because A and B are frictionless. Okay, we house the ball bearing, yes or no? Okay, okay, I'm going to stop here. I will see you guys, some of you tonight, some of you, I will see you on Wednesday.